Now we are going to discuss about question number 22. Two charges plus or minus 10 microcoulomb are placed 5 millimeter apart. So in the question they have mentioned there are two charges. One is minus q and another one is plus q are placed 5 millimeter apart. The distance between the two charges is 5 millimeter. And you know this distance 5 millimeter is termed as a 2a. If you take the midpoint of the dipole, then from the midpoint to any one of the charge, the distance is 2.5 millimeter and it is termed as A. And they have assumed a point P on the axis of the dipole. So the distance of point P from the dipole center is what? 15 centimeter. And that point P should be considered in the direction of in the side of the positive charge. They have mentioned that point P is taken on the side of the positive charge. Let's take point P in the side of the positive charge. Here you have to determine the electric field strength due to the dipole. Let's take the distance from the midpoint of the dipole to point P as r, and that is given as 15 centimeter. Okay, let's solve it. R is equal to 15 centimeter. You convert it into meter, so 15 into 10 power minus 2 meter. And A is equal to 2.5 millimeter. Let's convert it into meter. So it is 2.5 into 10 power minus 3 meter. Now, what is the electric field strength at point P due to the dipole at an axial line? So it is E axial is equal to 2P divided by 4 pi epsilon naught R cube. So 2 into P value. You have not calculated the P value. So let's calculate. P is equal to 2QA. So it is 2 into, what is the charge value they have given? It is, for the plus charge, it is 10 microcoulomb. And for the minus charge, it is minus 10 microcoulomb, right? So you need not want to include the minus sign. You know dipole moment. The dipole moment means you have to take the product of magnitude of any one of the charge and the distance of separation between the two charges. So let's take it as positive itself. So 2 into 10 into, convert this into convert the microcoulomb into coulomb. So 10 into 10 power minus 6. It is simply 10 power minus 5. So I have to write 2 into 10 power minus 5 into A value. A value is 2.5 into 10 power minus 3. And what is the answer for this? 2 into 2.5 is 5. 5 into 10 power minus 8. The unit of dipole moment is coulomb meter. I have calculated the dipole moment and now I am going to use this value here. So 2 into 5 into 10 power minus 8 divided by, 1 by 4 pi epsilon naught is what? 9 into 10 power 9. So let's write that. 9 into 10 power 9 divided by r cube. What is r cube? 15 into 10 power minus 2 the whole cube. And now the answer will be 2 5s are 10, 10 9s are 90 into 10 power 1 divided by 15 cube. What is 15 cube? So let's calculate into 10 power minus 2 the whole cube. It is minus 6. The answer for 15 cube is 3375 into 10 power minus 6. Here 90 into 10 is 900. So let's calculate 900 by 3375. 900 by 3375 gives 0.266 into 10 power minus 6. When it goes to numerator, it becomes 10 power plus 6. So 0.266 into 10 power 6. And we can write that as 2.66 into 10 power 5. Okay, and it is the value of electric field in the axial line. So what is the unit of electric field? Newton per coulomb. So this is the answer in the axial line. And next, they are asking you to calculate the answer in equatorial line also. See the diagram B. Now they have assumed the point B in the equatorial line. What is the answer for what is the formula for electric field due to equatorial line? It is simply P by 4 pi epsilon naught r cube. You know, axial line is 2 times greater than the equatorial line. So P by 4 pi epsilon naught r cube. What is P value? 5 into 10 power minus 8. And you have to take this as 1 into. So 1 by 4 pi epsilon naught is 9 into 10 power 9. by r cube. It is 15 into 10 power minus 2, the whole cube. 5 nines are 45 into 10 power 9 minus 8 is 1. 15 cube is 3375. 10 power minus 2, the whole cube is 10 power minus 6. And now 45 by 3375. It gives 0.0133 into 10 power 1 minus 6. Minus 6 when it goes to numerator it becomes plus 6. So 1 plus 6 is 10 power 7. So take the decimal to 2 places right side. So it becomes 1.33 into 10 power 5. Okay. So this is the answer for equatorial line. E equatorial is 1.33 into 10 power 5 Newton per coulomb. And now listen children, I have solved through the formula method, but I can give you one alternate method to solve equatorial line. You know, equatorial is E axial divided by 2, right? You know, E axial is 2 times greater than E equatorial. So I have taken E axial by 2. Already I have calculated the answer for E axial. That is 2.66 into 10 power 5 divided by 2. And now the answer is 1.33 into 10 power 5 Newton per coulomb. You can use the alternate method when you don't find the time to complete the answer.